Welcome back. So now we will go on to topic 2, which is all about finding the distance between 2 points in the plane. So as you guys know, I am a firm believer that you should know where formulas come from. So we're going to derive the distance formula. So suppose we are given 2 points, x1, y1, and x2, y2. So let's call this bottom one x1, y1, and then the top x2, y2, right? So it's in a rectangular coordinate system, so the xy plane, right? So the distance between the 2 points can be actually found using the Pythagorean theorem. So over here, so this blue line, we're going to call it D, right? So our goal is to find a formula for D, right? The general formula. So how are we going to use the Pythagorean theorem? So first of all, so I know in this class we never talked about the Pythagorean theorem, but I remember there was a concept question that asked about the Pythagorean theorem, and I'm pretty sure all of you got it correct. Right, so, but just to reiterate, so the Pythagorean theorem, if I have a right triangle, okay, and then I have AB, and then C is the hypotenuse is the longest side, right? If I have this, then I have a squared plus b squared is equal to c squared, okay? So this is the Pythagorean theorem. Right. So how will this work in our case? So you can kind of, there's a figure over here, right? But I'm just going to kind of replicate it. So in order to do this, so it's not easy to find the distance when it's like this. However, we can find it like horizontally and vertically. So let's do the vertical one first. So I'm just going to draw this as straight as I can, right? And so let's pretend so now at this point right here, right, this would be x2, y1, right? So it's over x2, and then we go down y1. And then let me draw it horizontally real fast. Right? So this is it. And then, so since there was a sharp turn, this is actually a 90-degree angle. Okay, so this is how we can use the Pythagorean theorem. So before we do that, so I know what C is. So in this case, our C is our D. But what is A and what is B? So for A, okay, it is the horizontal distance, right? So how can I do that? So the horizontal distance, it is your x coordinate, right? So it will be let me write it in different colors since there's a line here. So it's going to be the distance between x2 and x1, right? So, and I'm going to put absolute values because it's the distance. So yeah, so if you subtract them, if you get a negative number, you do the absolute value, so you get a positive number, so it's the distance, right? And then over here, and then now we want to find the vertical distance. How do you find that? You just subtract the y values. So it would be y2 minus y1. Again, for safe measures, we're going to do the absolute value in case, if someone actually named this one x2, y2, and then x1, y1. Right, so that's why we have the absolute value, because like as you can see, if we subtract x2 with x1, it's obviously going to be positive because x1 is in the negative, would be negative. So a positive minus a negative, that's positive plus a positive, right? But that's essentially like if people switched points. So that's why we put the absolute value there, right? So now that we've found A, B, and C, what I'm going to do is we're going to use the Pythagorean theorem, right? So I'll do that in blue. So we have A squared plus B squared is equal to C squared, right? So, but what is our A? Our A, we've established, is our x2 minus x1 quantity squared plus y, and then B is y2 minus y1 quantity squared, and then c is d. So this is d squared, right? That's what you do when you plug in the values. So one thing, so the absolute value ensures positivity, right? However, when you square a value, what do you get? You always get a positive number. So we can actually, so we don't have to worry about these absolute values anymore. It can just be x2 minus x1 quantity squared plus y2 minus y1 quantity squared equals d squared. Right? Again, the reason why we can just drop the absolute values is because it's squared, right? Because remember, -3 quantity squared is +9. So in this case, the absolute values are redundant, right? So again, just a reminder, what is our goal here? Our goal is to solve for d. So we're very close because we're at d squared. So what am I going to do? I'm going to apply the square root property. Okay, so this is going to be plus or minus. Okay, x2 minus x1 quantity squared. Right, and this is equal to d. Right, but however, d represents distance. Right, and then what is distance? Distance is always positive. So therefore, I can drop this negative, right, and it will just be positive. So I'm not going to rewrite it. I'm just going to erase it. Right, so this is always positive. Right, it's not negative because distance is never negative. It is always positive. Right, and again, so we don't have to write the positive because it's implied. So if there's nothing in front of it, we assume it's positive. Right, so this is our distance formula. So to state it more formally, so the distance formula is the distance d between the points x1, y1 and x2, y2 is d is equal to the square root of x squared minus x1 quantity, or x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So what am I saying? I'm saying that the distance between these two arbitrary points can be calculated with this following formula. So now that we've derived the distance formula, now we can apply it by doing an example. So the directions say find the distance between the following points. In our example, our points are -2, 3 and 4, -1. So first things first, write the general distance formula. So the general distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Right? And all this under the whole square root. Right? So now, in order to solve the distance, I just need to plug in some values, but we need to know what values are we going to plug in. So we're just going to establish them. So over here, I'll just call this x1, y1, and then this one can be x2, y2, right? So again, it doesn't matter. This could be x1, y1. This could be x2, y2. Just make sure you tell me. You can tell me by just putting it over this, or you can actually be more clear and by saying this. Okay, and then the x2, y2. Or you could, if it helps you, you can just say x1 is equal to -2, x2 is equal to 4, y1 is equal to 3, y2 is equal to -1. Right? Whatever helps you. Right? You can also do this for the midpoint formula. It doesn't matter as long as it's really clear what your values are. Right? So now let's plug it in. So x2 in our case is 4, x1 is -2. Okay, remember there's a minus here. And then y2 is -1 and y1 is 3. Okay, so now let's just simplify. So -4 minus -2, that becomes 4 plus 2. Okay, 4 plus 2 is 6. So this becomes 6 squared. And then -1 minus 3, that's also -1 plus a -3. So this is -4 quantity squared. 6 squared is 36. -4 quantity squared is 16. 36 plus 16, that is 52, right? So before we're done, we have to make sure that this is as simplified as possible, right? So 52, I know that 52, that 4, or actually, let's just rewrite this as uh, um, a product of prime factors. So I have 52, okay? I know that 52, so I know 4 goes into it, right? You can also say 2. Again, it doesn't matter what order you put them in. 52, 4 goes into 52 13 times. 4 can also be rewritten as 2 and 2. 13 is a prime number, so it can't be separated anymore. So how can I rewrite 52? I can rewrite it as 2 squared times 13. Okay, remember when for every factor we want to look at the power and compare it with the index. And if it's equal to the index or greater than the index, we have to simplify it. So in this case, if there is nothing shown by the square root, what does that mean? It means that the index is equal to 2. Right? So again, if we use the multiplication property, this is 2 squared, and then this 13. Okay, so the square root of 2 squared, that is 2. Square root of 13, 6. Right, so therefore, our distance between these 2 points is 2 square root of 13.